Now let's welcome to the new video. It is about the class 8 chapter number 9 mensuration. So in this video we are going to discuss about all the exemplar questions basically of NCERT exemplar question of chapter number 9 of class 8, which is mensuration. So before going into the questions, we must discuss what are the main concepts of this chapter, right? What are the main concepts and what are the results, right? Basically, we must be discussing about the formulas, right? We must be discussing about the formulas. Several formulas are the formulae are given here: area of certain geometrical figure as well as the perimeter. So let us start from the starting. Basically, what is known as the perimeter? Perimeter is the length of boundary of a simple closed figure. Any kind of closed figure we see, be it a triangle, be it a quadrilateral, or be it a pentagon, right? So these are simple closed figure which are made up of straight lines. Usually we are going to discuss, we are going to have the perimeter and area formula of several closed figure, be it made up of with the straight lines or be it made up of with curved line like a circle, right? So the first result or the first concept is the length of boundary of a simple closed figure is known as perimeter. Perimeter means the total length of the boundary lines, right, of any closed figure. Then it is about the area. Area, what is area? Area is basically the measure of, area is what? Area is the measure of the region enclosed in a simple closed curve, right? A simple closed curve encloses certain region, right? And that region is basically given by this: the space enclosed within any closed figure, right? The colored portion or the shaded portion, the blue portion of this figure is known as its area. Is that clear? Now let's move to the next thing, that a rectangle, right? First of all, what is a rectangle? As we all know, rectangle is a quadrilateral having all the four sides right angles and all the four angles are right angles and opposite sides are equal and parallel, right? It is a rectangle, and as we all know that this is the length and this is the breadth, right? So what should be the formula? The formula should be what? The formula should be the perimeter. Perimeter formula of a rectangle will be 2 into length plus breadth. Clear? So what is the area of a rectangle? Length into breadth. We are just revising it, that's why I am going up with a greater speed, with a higher speed. Next formula is about what? Is about the square. So first of all, we must know that what is a square. As we all know that square is such a quadrilateral in which all the angles are right angles as well as all the sides are of equal lengths. So what should be the formula to find the perimeter of a square? As we all know, all of its sides are equal length, are of equal length. Now let us have this formula. So the perimeter of a square is 4 into side. You remember this. And area of a square is side into side. And always remember, all the areas should be written, all the areas should be written in what? In square unit. In square unit. And all perimeter are mere lengths, so perimeter should be written in normal unit. Clear? So it is about the square, area and perimeter of a square. We did it. Now let's move to area of triangle. What do you mean by triangle? Triangle is such an enclosed figure which is made up of what? Which is made up of which is made up of 3 straight lines, right? And as we all know, triangle has 3 angles on 3 sides as well as 3 vertices, right? And what should be the formula to find the area of a triangle? Basically, in any triangle, if you are given that the length of any side and the height of the triangle, that means the perpendicular line which is drawn from its opposite vertex. So it is the side of the triangle and it is the base, it is the perpendicular or the height of that triangle from the opposite vertex of this line, right, from the front one, from the opposite vertex. Clear? So basically it is the very popular formula to find the area of a triangle, which is half into base into height, half BH. Clear? Area of a triangle, half into base into corresponding height. Corresponding height means if this is taken as the base, this would be its height. If I would have taken this base, if I would have taken this one as the base, then it should have been the height. Clear? So this is another height, but the height may vary. Height may vary, height may not be same. Is that clear? Now let's move to what? Now let's move to the next formula, which is a parallelogram. Clear? So what is the area of a parallelogram? First of all, we must know what is a parallelogram. So parallelogram is such a quadrilateral in which both the pairs of opposite sides are equal and parallel. Clear? And as we all know that parallelogram has also a height, it should be the height. Clear? So if this is taken as the base and this is the height, then the formula to find the area will be base into corresponding height. Clear? Now if you ask, how did you derive this formula? Let us derive this. In short, I am telling you, basically looking at the diagonal, right? As we all know, previously we all have studied this, that a diagonal of a parallelogram exactly bisects the parallelogram into two equal or congruent triangles. Clear? Now let's have it. If this triangle has an area of half into base into height, this would be half into base into height plus half into base into height. If two halves are added, then they form what? They form 1 BH, isn't it? Half plus half BH will be 1 BH. Directly it should be written as BH. Clear? So it was about the parallelogram. So the area of a parallelogram is base into height. Very simple formula. The next formula we should know, or we should discuss, that area of a circle. What should be the area of a circle? Basically you must know it is pi r square, right? By the printing mistake, to some extent pi has been erased here, so we should write that instead it should be pi r square. We should know that how does a circle look like. So let's have the ready-made circle here. Basically this is a circle, right? Sorry. Let's draw this. If this is a circle and this is the center of the circle and this one is the radius, what is this called? This is the radius. R for what? R for radius. Clear? We must know what is the formula to find the area of the circle. It is pi r square. How much is pi? Pi is a Greek letter which is always denoted, which is always represented to evaluate, to give us a value of 22 upon 7 or 3.14. Clear? Is it clear or not? So pi may be given to you as 22 by 7 or 3.14, right? So it is the area of a circle. Now let's have this area of a trapezium, right? What should be the area of a trapezium? Before going into the area of a trapezium, we must know that what is a trapezium. So what is a trapezium? Trapezium is such a quadrilateral in which one pair of opposite sides are parallel, and the other pair of opposite sides are not parallel to each other, right? In this figure, as we can see, this side, right, this side is parallel to this side, and this side is not parallel to this side. Clear? So only one pair of opposite sides are parallel. Only one pair of opposite sides are parallel, and another one pair will be on parallel lines. Clear? So what should be the formula to find the area? As we know that if we take it as what? If we take it as the side A and this side as B, and this one, if it is the height of the trapezium, right, it should be, let's say it is H. So what should be the area of trapezium? Half into sum of the parallel sides into height. Clear? It is also given here, half into sum of the parallel sides into height. Is that clear? Now let's move to the another formula, which is known as rhombus, right? What is a rhombus? A rhombus is basically a parallelogram. A rhombus is basically what? Rhombus is basically a parallelogram, but in that parallelogram, all the sides are of what? All the sides are of equal lengths. The same sign denotes that all the sides are of equal length. Is that clear? Okay. Now let's have it. If it is a rhombus, and as we all know that rhombus is a parallelogram in which all the sides are of equal length, right, and all the properties of parallelogram are here in a rhombus. Clear? If here we have two diagonals named as D1 and D2, here the lines which are drawn in blue color are both the diagonals of the rhombus, right? And if the lanes of both the diagonals are given to you, then what should be the area? Area would be half into D1 into D2. Clear? What is D1 and what is D2? Or what are D1 and D2? D1 and D2 are both the diagonals of the rhombus. Is that clear? Done. Okay. Now let's move to the next formula, which is known as what? Which is about the solid figures, right? Let's have the solid figures here. So solid, in the first of all, we must know the formula related to cube, right? It is about the cube. So what is a cube? As we all know, cube is such a solid figure in which all the three dimensions are equal, all the three edges are equal. That means if I take it, this one as the length L, if this one as B and this one is H, all of them would be equal. L is equal to B is equal to H in a what? In a cube. This is a cube. Clear? So can we name all of these edges as a single entity, as A? Clear? So if A is the every edge of a cube, then what would be the formula to find the lateral surface area? Lateral means except the roof and the base, how many surfaces we are left with? We are left with LSA. We are left with 4 surfaces. So one of the surfaces has an area of A square. So 4 surfaces will have an area of 4A square. And then let's move to the total surface area. Total surface area of a cube. What should be it? So basically there are 6 surfaces. All the surfaces are of equal measures, right? So all the surfaces are square surfaces. So every surface has an area of A square. So all the 6 surfaces has an area of what? Has an area of 6A square, right? Is that clear? So lateral surface area and total surface area of a cube are gone. Now let's move to the lateral surface area of a cuboid. So what is the meaning of a cuboid? Let's have it. Let's have it. Cuboid is such a solid figure where the length, breadth, height and length, breadth and height are not of equal length. And specifically all the faces, all the 6 faces of it are rectangular, right? It is a cuboid. It is a cuboid. Clear? And this is the length. If this is the length, this is the breadth and this is the height, so lateral surface area will be what? Lateral surface area LSA will be 2 into L plus B, length plus breadth into height, length plus breadth into height. What should be the total surface area? Total surface area is equal to what? Twice of LB plus BH plus LH. Clear? Is it clear? So these are the formula: lateral surface area, total surface area. Then let's move to the lateral surface area or curved surface area of a cylinder. So let's have it by raising it. Let's have it. Okay, sorry. Now let's move to the next formula, the lateral surface area. The lateral surface area or curved surface area of a cylinder. So first of all we must know what is a cylinder. So cylinder is such a solid figure which looks like this, and particularly it is a right circular cylinder. The cylinder has 2 flat surfaces and 1 curved surface, right? 1 curved surface. Basically cylinder has a height of, if this is of h length, this would be its r, radius of the base. It is the base. So what should be the lateral or curved surface area of a cylinder? It is the same as that of the lateral surface area, which is basically 2 pi r into h. R is the radius of the base. R is what? The radius of the base. H is the height of the cylinder, how high the cylinder is standing. Is that clear? Now the total surface area of a cylinder, let's have it. So total surface area of a cylinder, you remember this formula. It's not the time for the explanation of the formula or derivation of the formula. Rather I would say you the total direct formula. You remember these all, right? So the total surface area would be what? 2 pi r into r plus h. Clear? Okay. These are the formula related to the cylinder. Now let's move to the total surface area of a cylinder. It is done. Okay. Now let's move towards to find the volume, right? So first of all we must know what is the volume. Volume means what? As we all know, volume is the amount of space occupied by a solid object. That means if this tablet or these gadgets are occupying certain space, that means the amount of space they are occupying, that is the volume. Clear? If the amount of space that I occupy to sit, so that is my volume. Volume is basically the measurement of the space, amount of space. Clear? So the very easy and very popular volume formula to find the volume of the cube or of a cube is basically side to the power 3, right? Side to the power 3 or a to the power 3. And the next formula is about what? And the next formula is about to find the volume of a cuboid. Cuboid is basically what? Cuboid is basically has all the different edges, length, breadth, height, so it would be written as L B into H. Is that clear? And one more important thing you should remember, that volume is always written in cubic unit. Volume is always written in cubic unit. Is that clear? And the next formula is about the volume of a cylinder. What should be the volume of a cylinder? the volume of a cylinder is pi r square h. Clear? What does r stand for? R stands for the radius of the base. Is that clear? The radius of the base. And h is basically height of the cylinder. Now let's have the formula or the interconversion of capacity and volume, right? As we all know, capacity is measured in centimeter cube, right? Is that clear or not? Sorry, capacity is written in or measured in milliliter or liter or anything else. The units are there, basically liter. But volume, what does which resemblance does the volume have with capacity? So capacity and volume can be interconvertible. If we could be able to know that what is the volume of the solid figure, then we would have found, or we can find what we can find, how much solid or how much liquid can it get fit, right? So as we all know, 1 centimeter cube volume can fit 1 milliliter of liquid. Usually liter has the unit as ml, right? It is written as this ml. And as we all know, 1 liter is equal to 1000 centimeter cube. Clear? And 1 meter cube is equal to how much? 10 lakhs centimeter cube, right? So if 1 liter is 1000 centimeter cube, 1000 into 1000, so it should be 1 liter is equal to 1000 liter. Clear? 1 meter cube is equal to this much of centimeter cube. That doesn't matter. The only thing which matters is that 1000 liters. So if any solid figure which has a volume of 1 meter cube, that means it can fit 1000 liter of liquid. Clear? If a solid has 1 centimeter cube of volume, it can fit 1 milliliter of liquid only within it, right? So in this video we discussed about all the formulae of this chapter mensuration. So it would be very lengthy if I start doing all the problems in this chapter or in this exemplar PDF. Now we would be stopping this video, and in the next video I will be bringing all the suggestions, problem solving or problem solutions and answers along with all the questions. Let's wind up this.